Hi, it's Chrissy from the Hickory Corner Branch Library, and today I want to show you how to do some fun STEAM activities for the 4th of July. So the first experiment I'm going to show you is candy chromatography. Now Miss Lauren has a video in which she did a candy chromatography experiment using Skittles, and she had all different color Skittles. And I'm going to do the same thing but put a patriotic twist on it because this time of year you can find red, white, and blue Skittles at the store. So that's what I have here, and I made a pattern of red, white, blue, red, white, blue, red, white, blue, all the way around my plate. And now I'm going to add some water. My water is pretty hot here, but you can experiment with different temperatures of water, especially if you're working with younger kids. You might want some cooler water or lukewarm water. It's just going to affect the speed at which the experiment happens. It's still going to happen. You're still going to have a reaction either way, but it's a little quicker with hot water. So I'm going to just pour this on here right in the middle of the plate. Let it go out so it's underneath all of the candies. And then we're going to start to see what happens here as the water is sitting under the candies here. It's starting to dissolve them because the candies are soluble. That means they dissolve in water. So they're starting to dissolve and you're starting to see the colors coming out of them. And it's really cool because they kind of stay in their lines as they go. Even if you swirl it up a bit, it still finds its way back to this. So let me give you a little closer look of this here. So here we're getting a close-up of the color as it runs off of the Skittles and into the center of the plate. So we have red, white, blue, red, white, blue, and it looks really cool. And now a couple minutes later, you can see it's almost all the way to the center of the plate, and you can see some of the colors have mixed a little bit. We're seeing a little bit of purple in there, but for the most part we're seeing the red, white, and blue. It's just really neat. This is a fun activity to try at home. So now we're going to move our candy chromatography off to the side and move on to experiment number 2. You can see it swirling around now as I move it. Now we have purple. Okay, so now we're going to make some milk fireworks. So you're going to need some kind of dish or just an aluminum pan, whatever you have. So I'm going to dish there, and we're going to be pouring milk down on the bottom. I'm using 2% milk because that's what I have here. So I'm just pouring it just to basically cover the bottom. And then, again, I want to put a little patriotic twist on this. I'm going to use a star cookie cutter and put it right in the middle there. And then I'm getting my food coloring, and I'm going to drop some drops right in with the star here. So how about I do some red, and how about some blue around as well? Blue, blue. And it is spreading out a little bit, but for the most part it's kind of just staying there because this is water-based, and although the milk also has water, it also has fats and proteins in it that are kind of slowing that. If I started stirring it, of course it's going to turn purple, it would mix together, but for right now it's kind of sitting there. Now I'm going to use some dish soap. So I'm going to use a Q-tip and dip it in some dish soap. We're going to watch what happens when I stick this down into the middle of my star. So now, when I put the Q-tip with the dish soap in there, we're going to put it right in the middle. All goes out to the outer edges. And now let's watch when I actually lift up. It explodes out like fireworks. So we can still see it swirling and moving around there. And if I actually add more soap, it'll go out again and it swirls around some more. And so let's talk about why that's happening. So the food coloring is swirling around like that and just kind of moving all on its own because of a reaction that's going on between the soap molecules and the milk. So soap molecules have 2 different ends. One end is hydrophilic. It loves water. The other end is hydrophobic. It doesn't like water, but it does like fats, oils, grease, all that kind of stuff that we need soap when we're cleaning stuff, right? So when I added that soap there, it's attracting all of the fat and proteins that are in the milk. So it's actually moving, they're moving around and being drawn towards the soap. Whereas the water stuff is kind of going more towards the outer edge. It's going away from it. Then later, if you're doing dishes or something like that, what happens is the soap molecules, it's able to soak up all of the fats and oils and grease and the proteins, but then it's able to dissolve in water, kind of like the Skittle experiment. It's soluble, so it's going to dissolve in the water because of the hydrophilic end of the soap. Okay, so when I first added the soap, I broke the surface tension. You may have heard of surface tension before if you watched the video of me and Miss Andrea doing floating chalk art, and I described what surface tension was. So in this case, I broke the surface tension, and then like I said, because of the different ends of the molecules, that's where the reaction then started happening. We started seeing everything moving around. But it looked really cool when we first did it. It was like fireworks. And this is something you can do over and over. I could dump this and I could use some more milk, or like I said, I can continue to put the soap in. And I could always get another end of the Q-tip, or use your finger in the soap and just put it in, and it'll continue to swirl around until there's too much soap in there that the soap changes the reaction at that point. But you can do that again and again, and that's lots of fun. So now a third thing I wanted to show you is actually another video that I already have out, and that is about making rockets. So definitely look for that video. That was done back in April, and it was right after Easter. My kids had gotten some candy, and I used an a mini M&M container, which you can also use M&Ms for the water solubility test, the candy chromatography. So you could do that, use M&Ms as well for that, and see how it's a little bit different when there's chocolate involved. What happens to the chocolate? Does it dissolve too? Something to try out. But I have this tube here, so for 4th of July, it's really easy to decorate this and make it like a little rocket. So this is a film canister instead. You can still get film canisters. You can order them online if you want to get a bunch of those. And all I did here was just took a piece of paper and I made it into a cone shape and covered it in aluminum foil, and then you can hot glue that on to the top if you want to top. So just like this, I have just a circle of cardboard, or it could be, you know, from your cereal box, or it could be cardstock. But you just make a circle, cut a line in it, and then bend it up to make your cone shape. And then once you get the shape you want, you tape it down. If there's any little extra pieces like this, you can just cut them off. And again, cover it in foil and just attach it to the top if you want to have a little cone part on the top of your rocket. And then otherwise, there's all different things like washi tape, different colored tapes that you can put on there to decorate it. You could use stickers. A lot of times I just use like all the little star stickers on there just to make it look really patriotic. And then you just need Alka-Seltzer, or the generic form of that you're gonna put in here, and put water on the other end, and then stand back and wait and see what happens. So I hope you had fun with these experiments, and I hope you have a great 4th of July.